This is lesson 15-5, graphing equations with more than one operation. Our essential question, how can you graph a linear equation with more than one operation? And this picture is just a quick example of what our graph and our equation might look like. We have two vocab words, independent variable are the input values of an equation, and dependent variable are the output values of an equation. Alright, so very similar to what we did in the last lesson, but now we just have a few steps. So we're going to plug in these numbers in place of x to solve. So we have y equals 5, and in place of the x we have a 1, minus 1. So y equals 5 times 1 is 5, minus 1 is 4. Now I'm going to plug in a 2 in place of the y. So y equals 5 times 2 minus 1. I'm just using this equation every time. So y equals 5 times 2 is 10, minus 1 is 9. And our last one, we plug in a 3 in place of x. So y equals 5 times 3 minus 1. So y equals 5 times 3 is 15, minus 1 is 14. So let's go ahead and graph. Remember, the x tells us how many to go over, the y tells us how many to go up or down. So our first one is over 1, up 4. Next one, over 2, up 9. Last one, over 3, up 14. And my graph actually doesn't go to 14, so I'm going to make an educated guess and put it about there. And again, it's going to be a linear equation. Example 2, we have y equals 6 plus 2x. So let's start plugging in these numbers for x. Our first one is a 1 in place of the x. So y equals 6 plus 2 times 1. All I did was put a 1 in place of the x there. So remember, you always have to multiply before you can add. Think about the order of operations. So y equals 6 plus 2 times 1 is 2. 6 plus 2 is 8. Now we plug in a 2. So y equals 6 plus 2 times 2. Y equals 6 plus 2 times 2 is 4. 6 plus 4 is 10. Last one, 3. So y equals 6 plus 2 times 3. Y equals 6 plus 2 times 3 is 6. And 6 plus 6 is 12. So let's go ahead and plot those points. I'm going to actually extend my graph a little bit so that I can plot them. So here would be 10, 11, 12, and I can actually stop there for this one. So we have our first one, over 1, up 8. Next one, over 2, up 10. Last one, over 3, up 12. Connect the points, and you have your graph. Now we have y equals 2x plus 1, and we're going to plug in these numbers for x. First one is 1. Y equals 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3. Then we do it again. Y equals 2 times 2 this time, plus 1. 2 times 2 is 4, plus 1 is 5. The last one, we plug in a 3 in place of the x, so y equals 2 times 3 plus 1. So y equals 6 plus 1, which is 7. And now we can graph. The first one, over 1, up 3. Next one, over 2, up 5. Last one, over 3, up 7. And we connect our points. Last one, we have y equals 2x minus 4. First one is to put in a 1 in place of the x. Remember, if they don't give you the values for x, you can choose. Sometimes they will tell you what they want you to put in for x. So y equals 2 times 1 minus 4. Y equals 2 times 1 is 2 minus 4. Remember, think about it on a number line. You can even draw it out if you want. Is going to be a negative 2. We rewrite the equation, this time with a 2 in place of y. So 2 times 2 minus 4. So 2 times 2 is 4, minus 4 is 0. The last one, we have a 3 in place of the y. So we have 2 times 3 minus 4. 2 times 3 is 6, minus 4 is 2. And now we graph. Over 1, down to negative 2. Over 2, and we stay on 0 so we don't go up or down. Over 3, up 2. Connect the points. Okay, you're going to do the same thing for these 2 practice problems using the t-table and graph the equation. Don't forget a word problem or a question and rate your understanding.